ATX. ATX, what it does is a power supply for computer UPS. So guys, what you can see right here, it is for computer CPU actually. So what it does is it supplies power to which is the central processing unit. And if you look at the front, you see there's a fan. What it does is to cool the system in there. But recently, people have been using this system they've been turning it into a power bench, which means these wires you're seeing right here can be used to power devices. There are some currents. If you use your multimeter to test each one of them, you can get some voltage from it, which you can use to power other things. Some people use it for charging. You can get about up to 3.3 volts. You can get 5 volts, and you can also get a 12 volt from it. So guys, we're going to open it up. We're going to take it apart so you can see how the inside looks like. It's a little bit dusty. So you can see how the inside of this power supply looks like. Right here we have the transformer. This is where the input power comes in. We have our two big capacitors. We have a transistor right there, and we have this one is for a resistor, a big resistor. So what it does is to just distribute power to different parts of the central processing unit of the computer. So that is what it does. And if you take a look at this connector right here, you will see that this connector is this should be around 20. The connector right here is up to 20. So this power supply is an old power supply for central processing units. The old one comes with 20 connectors, while the recent one comes with 24 pin, which is the more advanced one. It has other things you can connect it to. So guys, recently people have been using this as a power bench to charge 3 volt battery or 12 volt batteries and so on. So one way we can find out is by assessing the power source. If you take a look at it right here, you can see this one is in, this one is out. So what it does is you plug in power here to get power into the system, and to take power out, this is where you plug in. There's another connector which is being plugged here to the central processing unit. So part of all these ones are to distribute voltage of different levels, such as 3 volts, 12 volts, 5 volts, to different parts of the central processing unit. And you can see the connectors are much. So they have different functions that they do in the central processing unit. And this one is a 20 pin connector. So this one is an old version of the newer power supply. The newer one are 24 pins, but this one is just 20 pin. So what we're going to do right now is I'm going to be plugging it to a power source, and this is how it is. This is how it looks like. Okay, so we'll be plugging it to this one right here to send power to the system. Okay, to send power to the system, and I'm just going to plug it. So right now there's current flowing into the system right now. And how can you tell is by using your multimeter to test some of this pin. So in most cases, they are called ATX. So what you would do is that if you go to Google, you can download a diagram for ATX, Central Processing Unit diagram. So it will give you these color codes, these wires you're seeing right here with different colors, they have each voltage. Like the red one right here, these are for 5 volts. The yellow one right here, these are for 12 volts DC. So there's one of them right here is for 3 volts. So that's what they do. So one way you can check if there's voltage in it, you can see this green one right here. We're going to connect one of the probe to the green, and we'll be connecting the other one to the other side. You will see it's going to read. I hope you guys can see clearly. You'd see it's going to read. Oh, I think the polarity is in reverse. I'm trying to be careful so you guys can see it clearly. Okay, I think this is okay. Okay, the first one is connected to the green, and the other one is connected to the. You can see the multimeter turning to the right hand side. So there is voltage in this part, and if you move it to the other side, you can see the multimeter reading. The other pin, you can see there's voltage there. Let's try this side. You can see there's voltage there. It's reading. So each wires right here, like the yellow one is for 12 volts, and the red one is for 5 volts, and there's one of them right here is for the 3 volts. So people use this as power bench. So what they do is they will cut this pin this connector away, so they will have access to the wires, and they can use that wire to be able to plug it to use it to charge either a 3-volt battery or other appliances. So that's what people do right now. So these power supply are very good, and I showed how the front looks like. You can see it has a PC fan right here. What it does is to cool the system, is to suck air from inside the system right here, so that it can run very, very smooth at optimum temperature, which is good. So you can see it. This is the in, this is the out. So guys, when trying to get a power supply like this one, I would advise you go for the 24 pin. This one is for the 20 pin. The 24 pin has more functions than this one. It has more functions. That's what I would say. And I think it has even more connectors. You can see we're having 1, 2, 3, 4. We have this one 5, and we have another one. Yeah, this one is for the PC fan. So you can see this one has less connectors, though they look much, but the 24 pin has more functions because they are much advanced. So these ones, I think these ones were created maybe around 2003 or so. So they have less functions, but it will still work. So that's what people do. You can get a digital multimeter to test them. You'll be able to locate each voltage: 12 volts, 5 volts, 3 volts, and there's another one in black. What it will do is to turn on the power supply of this, and it will start working, which is going to activate the PC fan right here. So what you need to do is to go to Google, download the ATX schematic diagram, and you'll be able to see more information about this ATX, about this Central Processing Unit's power supply. There you'll be able to see the one of the 20 pin and the one of the 24 pin, how they look like. So this is how the inside look like. You can see it. Just a transformer. We have a big resistor right there. We have a transistor. We have a capacitor. You can see how mighty these capacitors are. They're very big. They're very big. I'm trying to see if I can see the microfarad. It's inside there. They're very, very, very big. So it works really well. So that's what people are using now. They're using it as a power bench to power other things. And someone asked the question if these can push. I think some of this one can push the amperage and not that much. So it's best. Someone asked the question if this can charge a 12-volt battery. Well, what I would say is no, because for you to charge a 12-volt battery with this, I think this outputs around just 12 volts. 12 volt from this yellow wire right here, and I think from one of this red will give you 12 volts. So for it to give you 12 volts, you can't charge a 12-volt battery with a 12-volt source. What you need is something around, at least from around 14, 15 volts should be able to charge a 12-volt battery to the way it's supposed to be charged. So using a 12 volts would not be that efficient, and the amperage from these guys are not that much, So that is how it is. So guys, later on, what I'm going to do is I'm going to find a way to strip these wires out and put a tape to put each voltage on them. I've seen people done that. They use this paper tape to tape each of the wires together and label it 12 volts. They label the other one 5 volts, and they label others 3 volts depending. And most times they do put the amperage on it so that you'll be able to know which one is which when you're about to use it for other applications. So the voltage adjusts, each of the wires are the same. Sometimes it is confusing. These ones right here, you might feel they are different types of connector, but they are not. You can see their label. This one is PC3. This one is PC5. They have each places or each areas they are connected to inside the CPU. I think I'll be showing that later on in a different video. This one is PC7. This and the one at the back is on PC6. So they are all basically the same wire. If you look at it right here, these two connectors, you will see that there's a yellow here and there's a red here. They're basically the same thing. If we're to use multimeter to test this one and this one, they're the same wires. So what they just do is to find a way to get them out here, use it to connect, plug it to other areas in the central processing unit. So that is how it works. And this one, I feel, this one works. It doesn't work with, what is it called? Temperature sensor. Some people feel it works with, I feel maybe the newer model might be working with temperature sensor. This PC fan right here, which is for the cooling of the system. This is how the back looks like. And this fan is very powerful. Very, very powerful. Very powerful. And one way you can find out is if we are to use, if we are to test it, it runs very, very fast, and it's nice. So the fan right here, at the place where the fan is connected, let's unplug this so that we don't get shocked. The place where the PC fan is connected is this part right here. You can see this white connector. It has 2 pins. That is where the fan is connected. And guys, for you to be able to read this panel and understand it better, what the manufacturers have done is that they've labeled some of the connectors right here. That's one thing you need to know. So where this white part is, this connector that has 2 pins here, I don't know if you can see it clearly. It is written on the front of it, on the board here. It is written fan right there. So that is where you plug the PC fan to it. And some of this wiring, for you to be able to access this system to turn it on, you have to use the green and the gray wire. Where is it? Okay, yeah, this is it right here. You can see this gray wire, this one right here, and there's another one, a black wire. You have to use one of these black wire. What you do is to connect them together. It will activate the power supply. It will turn it on. And some of them are labeled down here. I don't know if you can see the label. You can see it's on and off. They have some writings there. If you can see, okay, I think the camera is focused right now. There is minus 12 volts. There is minus I think plus 12 volts right there, and you can see that is where each of these wires are connected to the board there. So even though without downloading the diagram, the schematic diagram on Google, you can just check the board right here and trace each line, because their voltage are written on the board right there. But I would advise you to download it from Google. It will make it to be easier for you to understand. And each of these connectors, mostly this one with the 20 pins, they are all labeled. They are all labeled, and it will help you to be able to understand the system better. So guys, thank you so much for tuning in. I really appreciate you guys for your support, for always tuning in to my live to watch. Thank you so much. So later on a different video, I'm going to label each of these wires, so that, and I'm going to be putting the voltage on them, so that I'm going to write down each wires, what voltage are they? Are they 12 volts? Are they 5 volts? So that it will be easy to be able to read. So that is how you do it. And once you know each voltage, you'll be able to know what pin to connect to what. Or the best way you can do it is by removing this 20 pin connector. Once you remove the 20 pin connector, you chop it off. You can have access to these wires, and you can use the wires to power other things, charge your batteries, and lower batteries, actually, not 12 volt batteries, and they'll work better. So that is how it works. You can see this one has a smaller transformer inside, and everything worked. And you can see these two green, they're connected to ground. That's why they're connected to the body of the housing of the power supply. And in most cases, these ones are used to switch it up from, sometimes some of you might be wondering, you guys might be wondering, why is this here? So these are the same thing as switches. You can see it is labeled 230 volts. Once you switch it to the other side, in most cases you will see 110. I don't know, let's try to see if it's going to switch. Good. I don't know if you can see it clearly. This is 115. This is 115 right here. So what it means is 115 volts AC. That is this. Then once you switch it to the other side, this is 230 volts, which means the system can run on 115 volts, and also 230 volts. So what you need to do is, if you are running your this power supply on a 230 volts, you can switch it to the 230 so that the system can handle the current that will be flowing in. Then once you want to, if you notice the power that you are using or your utility power is around 115 volts, then you put this switch to this other side, which is the 115. Then your system will be able to handle the power that is coming in. Because in most cases, you can't use, if you have a 230 volts coming in from your utility power, it is best to just switch it to the 230 so that the system will be able to handle it very well. So that is just a switch. Most people think it is just there for design, but it is a switch to be able to switch the system to handle the power that is coming in, if it's a 230 volts or a 115 volts. So this is the input power. This is where you put you plug your this is where you plug the cable. You plug the cable right here, which is your inputs, and this one at the top right here, this is your outputs, where you send power out. And this power that is being sent out is AC power. It is not DC. That's why you see that the connector or the surface of this place is very big. So it's AC line that is coming out from this system. So this is in, this is out. So it's like sending AC current in, and you can also receive AC current out. So that's why this power supply, which is used for central processing units, and it is also called ATX, is also good for using it as your power bench. So it is a good system. You cannot not just having not just getting DC voltage from the system, but you can also get AC voltage from the system, which is good. You can get 12 volts, you can get 5 volts, you can get 3 volts, and you can also get your 230 volts AC from this side, and you can switch it up. What it means is you can switch it to be either 110 coming out. Let's check the inside. You will see it's a switch. I don't know if the camera is picking it very well. Okay, let's try to video it from the side. Though it's dusty because it has been, this system has been abandoned for a long time, but it's still working actually. I think this system has been for around maybe 10 years now. You can see how old it is. So that's a switch right there. So the switch is to be able to adjust the current that will be going out from the system. So that is it. And the green one is your ground, which is connected to the housing, which is very important. So guys, there you have it. This is how an ATX power supply functions. Nothing much to it. What you just need to do is to try to find a way to sort out each of this wiring. Most times they look confusing, but it's not confusing as you think. They are all the same wires. The wires that is connected to this connector is the same one that is connected to this. It's also the same one that is connected to this. You can see them. They look much, the connectors. I think these are 1, 2, 3, 4, and 5, 6. But they are all the same wires running through each one of them. And what they basically do is to distribute power evenly to different sections or different parts of the central processing units of your computer. And this one plays a major role of all of them. This one is the 20 pin, which takes in most of the control, and that is just it. But I would advise you to go for the one of the 24 pin, which has more functions. That would be best to go for that one. So guys, that is how everything functions. So this is how you close it. Okay. So you can see this is how it looks like. This is how it looks like. Some of you might have seen it before. This is how the power supply looks like. This is the side. You can see that it is boldly written, danger, do not open, dangerous voltage inside. Because if you're not careful, if it's plugged in and you're using your bare hands to touch the transformers and parts of the components in there, you can get shocked, which is very dangerous. So this is how the system is. You can see this place is for the system to be able to suck air in, and this one is going to suck the air out from the system, which is the fan. The fan is not connected to anything related to temperature sensor, so the fan is always switched on. The fan is always running 2-4. That is how this one is being built. This one is an old ATX, so the way this one works, the fan is always on 2-4. It doesn't have a temperature sensor whereby it's going to read parts of the components are very hot and thereby turning on the fan. So it works. So, and one other thing you can consider is you can see at the body here we have a label. You can see the model, you can see the input power that it takes, which is good, from 100 to 127 volts AC, which is good. That's good actually. And you can see the amperage, 7.0 amp. And it can also take 200 to 240 volts, which is also good. And the frequency is written 50 to 60 hertz, which is perfect. So look at this is the second one, which is the output power. The output power can also be used to power other things too. You can get up to 100 to 127 and 200 to 240, which is good. Hello Tech Vegas, welcome. No. This is an ATX. It's a power supply for central processing unit of a computer, and this is how the front looks like. It has a big PC fan at the front here. What it does is to cool the system, sucks air out, warm air from the system, and it comes with these connectors. You can see them, this bunch of connectors. So so people have been hacking this system. What they do is to get it out from a central processing unit of any computer, and they turn it into a workbench. So what it means is they use it as a source of power supply to power either to charge a battery or to power other small appliances. And if you check, you can see this connector right here. It comes with multiple wires. So each of the wires here indicates the voltage of each it's okay, like for instance, the yellow one and the red together is your positive. That's where you get your 12 volts. And the red here, this red and this black, that's where you get your 5 volts DC from. And if you use the blue and one and the black right here, you will get your 3 volts. So people have been using this system to power so many things. Some also use it to charge these 18650 batteries. Some use it to power this, to charge these batteries also. So that's what have been going on. So I was just displaying, showing people how it is, how it functions, and how to hack the system. And people can also go to Google to download the schematic of this power supply. You can get it there on Google. Just put ATX power supply, and the schematic will be there, the diagram. You will see the label and everything. So that is how it works. So back to the the label at the body, you can see that it's showing the peak power, and each of the voltage which are written here, you can see the maximum voltage. Like I said, this power supply doesn't output much amperage. You can see some of them are around 3.5 amp max, so you don't need to exceed the system, and some of them are 2 points. Like for instance, now if we're to use the red wire, which is the 5 volts, the red wire and the black is for 5 volts, and the peak maximum amperage you can get from it, you can see it is written here, which is 2.0 amp maximum. So from the 5 volts, which will be tapping from this pin right here, we cannot use more than 2 amp from it. The maximum is 2 amp. So if we're to use 3 volts from this system, the amperage is around 8.0 amp. You can see it's not much. The 5 volt is also 10 amp, and the 12 volt right here is around 3.5 amp maximum. So when using it to power other things, it is best not to use it to power something that is very big. Why? Because the amperage are small. It's very, very small. You can see the output power is around 145 watts, so nothing much. So this is how it works. So with this label diagram right here, it will be able to guide you on how to use the system. Even though you don't know much about it, it is best to read the label right here to be acquainted with how it functions, the amperage, things you can use it to power. Like for instance, this 5 volt right here, you can see this 5 volts at 10.0 amp. With this, you'll be able to use it to power an 18650 battery. It should be able to power it very well without any stress. So that is it. But the 10 volts, the one on 10 volt right here, 10 volts max on, okay, I'm trying to look for the one of 12 volts. Some people said, can you use it to charge a car battery? I don't think so. So at this side here, it is written 12 volts at 3.5 amp. So you can see the amperage right here is very, very low. You cannot be charging a lead acid battery with this at 3.5 volts. It is very, very low to charge a battery of that size with 3.5 volts. So I would not advise you to use this power supply to charge a car battery. A car battery is too big for that. But if you were to charge smaller batteries like these ones, you can use the 3.5 volts. You can use the 5 you can use the 5 volts. Yeah, you can use the one of 2.0 amp maximum, the one of 10.0 amp. It will work well. So guys, thank you so much, and let's just see the inside once more so you can see it. There's nothing much going on this power supply. Nothing much. Please guys, it is best to remember that the board right here, most of the connectors right here, you can see they are labeled. Like this one is for the fan. You can see the on and off switch there, like this color black, and this other wire right here and this gray, they are for the on and the off. They are labeled right down here. So it is best to read the diagram so you can understand the system. And this one that is labeled this color black right here, it says on and off. So if you were to connect the gray wire to the black, it's going to turn on this system automatically. So what you can do basically is to bring out the gray wire from inside and the black wire, and you can connect a switch to it. thereby making it easy for you to turn it on and off. So what you have basically done is to turn the system into a bench, workbench, to be able to use it to power other things. So it's all about just sorting these wires out. Just get them arranged and label them so that it will be easy for you to use them. So that is how it is. Okay, what other thing am I missing out? Okay, yeah, you can see it. You can see this. It's very, very old. You can see how inside looks like with a big transformer. Okay, yeah, we can also check the transformer. Okay, transformer is not that big. That's why the amperage from the 12 volt line is maximum. It's around 3.5 amp. You can see it. So don't try to use it to charge a car battery. It's not possible. A car battery needs more amperage to be able to charge it, a lead acid battery. And you cannot be using this to charge a car battery of maybe 70 amp, using a 12 volt at 3.5 amp to charge it. It's not possible. I've seen some people try to use this system, this ATX power supply system, to charge car batteries, but it would not work. For you to charge a car battery of 12 volts, you need at least from 14 volts to 15 volts to be able to charge it very well, and the amperage needs to be a little bit higher so that you can charge the battery. Once the amperage is low, it wouldn't charge. It looks as if it's charging, but it's not charging. And once the voltage is almost the same, which is 12 volts, it would not charge also, because the voltage is not higher. The voltage needs to be higher than the initial voltage of the battery for you to be able to charge the system. But what I can advise is that you can use this to charge these batteries, these 18650 batteries. It will charge it comfortably well. I would advise you, when trying to charge these batteries, this 18650 battery, I would advise to use, you can see the label right here. I would advise to use the 5 volts DC at 10 amp maximum. I think that should be better. We have other option of the 5 volts at 2 amp. We have the one of 3.3 volts at 8.0 amp. So you can see it now. So I would advise you to use a little bit higher, because these batteries are around 3.7 volts. We can charge them at 4 volts. We can charge them at 5 volts. I think 5 volts should be able to charge them very well. And one thing I love about this, why it's going to charge these batteries very well and safely, is because the amperage of these guys are not much. The amperage are a little bit low, so it should be able to charge the system without any stress. Without any stress. And there are some of them you can combine the output. Like this one says maximum combined output power of 70 watts. So if we're to use the 3.3 volts and the 5 volts wires together, we should be able to get more amperage from the system. Why? Because each individual amperage of these wires are very low. So in most cases, they do combine them together to get high amperage from it. So that is it. So guys, when you're getting this, go for the 24 pin. Don't go for the 20 pin. The 20 pin are the older model. So that is what I will advise. and you can sort them out later on. These wires, the wires look all confusing, but really they are all the same wires. Once you can get the color code, like the color, the diagram for each of these colors, like the yellow ones are your 12 volts, the red ones are your 5 volts, there's another one right there, that's for your 3 volts. And so once you can just go to Google, download the schematic diagram of the ATX, you will see the color codes and the voltage of each of these wires, which will make it easy for you to be able to use this power supply. So this is what powers your central processing unit of your computer. It looks very small, but these connectors goes to different places or different channels to power various places inside the UPS. So that is how it is inside the central processing unit, CPU. I don't know why most times I do confuse it. Why calling it CPU instead of why calling it UPS instead of CPU, which is the central processing units. Okay. So guys, thank you guys for tuning in, and I think we'll call it a day for today's live. Call it a day for today's live. So let's put it back together the way it's supposed to be. So you can see this notch right here. So the notch, it's supposed to be at this side here. It's for the opening, so that the wires can flow out nicely. Good. So that is how it is. You can see the big PC fan. So this PC fan runs on 12 volts. So it also runs on the main power in there, which is one of these wires, which is the DC, the 12 volt DC, which is the yellow one and the black. So it is written there. Thank you guys, and I'll see you on the next video or maybe on the next live. I really appreciate you guys. You guys are the best. Take care.
people are supposed to watch. Almost 50. Look, you're not in the chat. My body.